this video, we are going to do some 6 questions here, mostly tested as 1 or 2 marks in board examination, previous board examinations. So let's begin with the first one. In the first question, which is based on the property called tangent from same exterior points are equal. So you can see in the figure common tangent AB and CD. So AB is a common tangent. By that it means to say that it is a tangent to this circle as well as to this circle. And similarly, we are given another tangent, and this is CD here, and it is tangent to common tangent to both. Now, what we need to prove here is that AB is equal to CD. This whole length AB is equal to CD. Now, as I said, it's based on tangent from same exterior point. So what you can see that this AE and CE are tangents drawn from the same exterior point. So I can say that the length of AE or EA is all same. So EA is equal to EC, and the reason, as I said, tangent from same exterior point. Now you can similarly figure out that here the length ED will be equal to EB. From the same reason, we can say that here EB is equal to ED. And the reason you must write tangent from same exterior point. Now, what in case if I add these two equations? On adding these two, what do we get? We get EA plus EB is equal to EC plus ED. Now check in the figure here. What is EA plus EB? That will give you AB. So this is AB. And likewise, you can see that on the right hand side, we have EC plus ED. So that results to give you CD. And that's how we say it's proved. Now you must write out the property here, tangent from same exterior point. The next question, which is again based on the same property that tangent from same exterior points are equal in length. So what you can see that in the figure here, two circles touch each other at point C. So this is the point at which these two circles touch. And what we need to prove here that the common tangent to the circles at C, that means they're talking about this tangent, that is this one, right? Prove that the common tangent to the circle at C bisects the common tangent PQ. So they mean to say that this one, right, this one, that is CR is bisecting PQ. In short, what we need to prove here that PR is equal to RQ. This is what we need to prove. Well, as I said, question is based on tangent from same exterior point. So first of all, as you can see that PR and CR are the tangents drawn to this circle with center A from the same exterior point. So I can say that RP is equal to RC. And the reason you should write tangent from same exterior point. Now look for the other circle here. Here too also you will notice that this is RQ and this is RC. They are drawn from the same exterior point. So I can say RQ is equal to RC. From these two equations, you can figure out that RC, both inside, right? RC is equal, RP is also equal to RC and RQ is also equal to RC. Therefore, we can say RP is equal to RQ from equation 1 and 2. And this is what we need to prove. Hence, we can say that this bisects. Bisects is what? Dividing into two equal parts. Now, in the third question, you can see that in this figure, well, first of all, I'll tell you that this row is based on the property that tangents from same exterior point are equal in length. So we are given AP and BP. You can see that AP and BP, right? These are tangents drawn to this circle with center O such that AP is given as 5. So the length of AP, this is the length of AP and this is given as 5. And we are given this angle, that is angle APP is given as 60 degree. What we have to find is the length of this chord AB. That's what we have to find out. Now check here. As I said, the property remains the same. We can say that PA is equal to PB, and the reason is tangent from same exterior points are equal in length. Now, if these two lengths are equal, if this is equal to this, what you can say, this is an isosceles triangle, and an isosceles triangle whose vertex angle is 60 degrees, an equilateral triangle. You can write it directly, and if you are not aware of this property, you may do it in a different way. Like what you can do here, that you can consider this triangle, that is the triangle. Let me shed the triangle I'm talking about. Yeah, you consider this triangle first, and in this triangle, what you can see that we have the length of two sides. The triangle I'm talking about is APB. Here you can see that these two lengths are equal. So as you know that angles opposite to equal sides are equal. So you can say that this angle is equal to this angle. And say if I name this as X, so you can say that since two sides are equal, so therefore the angle PAB is equal to angle PBA. So let's say they are all X. Now I can say that the sum of three angles of a triangle is how much? 180 degree. So you can figure out this is 2x is equal to 120 or x is equal to 60 degree. Now let's go through this triangle once again. In this triangle, we can figure out that this we got as 60, this we got as 60, and this was already given 60. So it's an equilateral triangle, right? So it's an equilateral triangle where the length of one of its side is how much? Given as 5. So what we know that in an equilateral triangle, all its sides are equal in length, right? All sides are equal in length. So therefore, we can say that all three sides are equal, which is PA should be equal to PB, which should be equal to AB. And since PA is 6, I can write this as 6. So ultimately, we have to get the length of AB, which is 6 centimeter. But as I said in the beginning, if you write statement, you do not have to write these things. Straight away say an isosceles triangle whose vertex angle is 60 degree is an equilateral triangle, and you can write the length of AB directly as 5 centimeter. Reason being here PA is 5 centimeter. Let's move to the next question now. The next question, which is an MCQ, and this is based on the property that radius is perpendicular to the tangent at the point of contact. Now, if I read the question, it says in the adjoining figure, we have to find the length of the tangent. And which is the tangent here? Tangent is this. So finding the length of tangent is same as finding the length of x here, because tangent is length of the tangent is mentioned as x and in the figure. Now, what I said in the beginning that is based on the property that tangent is perpendicular to the radius as at the point of contact. So this angle is 90 degree. Now check here, in this triangle I'm talking about, here you can figure out that in this triangle, it's a right angle triangle. So we can say that the square of the hypotenuse, which is OQ here, will be equal to sum of the squares of other two sides. So it should be equal to OP square plus PQ square. OQ, whose length is how much? As you can see the figure, the length of in the figure, OQ is given as x plus 2 is equal to OP, which is 8 here, and PQ, which is x. Now I'm good. A plus B whole square. This is what? A square, that is x square, plus 2AB is what? 4 times x plus 2 square, which is 4. 8 square is 64 plus x square. Now you can figure out here that x square get cancelled. So we are left with what? 4x is equal to, on transposing 4 to the other side, right? It's going to be 64 minus 4, that is 60. So x is equal to 60 divided by 4, and that should give you 15. So we'll say that the length of x we got as 15, and they asked for the length of the tangent, and tangent is PQ, which is equal to 15. So that's how we did this question. Let's move to the next. In the next question, we are given a figure. Well, this should not be a 1 or 2 marker. Should be tested in minimum 3 marks question. Two tangents RQ and RP are drawn from an exterior or say external point R to the circle with center O. So we can see in the figure we are given RP, right, and RQ are two tangents drawn from the same exterior point, right? And the angle RPRQ. So this angle PRQ, this angle is given as 120 degree. Then we have to find a relation here, that is we need to prove OR, this is OR, is equal to PR plus RQ. That's what we have to find out. Well, this question involves construction. Well, any question involves construction, students say that they find it difficult to remember what construction. Well, if you remember that in a circle, one thing is very clear, that in a chapter circle, if there is a construction, then it has to be, I won't say it has to be, but in 9 out of 10 cases, it's always the joining the center with the point of contact. So I'll be joining the center. So if you keep this thing in mind, it's going to be helpful in a questions involving construction of chapter circle. It's most of the time, as I said, 9 on 10 cases, it is joining the center with the point of contact. So I've joined this and this. Now, next, as I said, if I have not said anyway, I'll say that this triangle is congruent to this triangle. So these two triangles are congruent. And why? It's because of tangent. One is tangent from same exterior point, right? And these are radii, right? OP and OQ are radii, and this is common. So I'll first write down. I'll say the triangle OPR is congruent to triangle OQR, and that is by SSS, right? So actually in the exam, you have to prove it. Just don't write it. I'm writing it like this only. Now, if these two triangles are congruent, so I can say that this angle which was given as, let me once again erase this thing till here only. And let me tell you which angle was given, 120 degree. This was given as 120 degree. So I can say that by CPCT, these two angles are equal, and one of them, let's say this one, this one should be how much? 60 degree. So I'll say this angle is 60 degree. This angle is 60 degree. Now, once we write down this angle as 60 degree, let's figure out. In this triangle, we are going to apply trigonometry. Well, this is it always become difficult. So in your examination, you need to be broad-minded. By that, I mean to say when you're dealing with a particular question of geometry or maybe a circle, do not limit yourself with all the properties of circle. Well, obviously, you'll be first opting for the properties of circle. But if you are not able to solve the whole questions, always think about the other properties, particularly trigonometric ratio. And this is applicable particularly in a triangle when you know an angle and you have to obtain the relation between the sides. So now you see in this triangle, what you can see that we have this angle as 90 degree. Reason is radius is perpendicular to the tangent at the point of contact. So this angle is 90 degree from the property. Radius is perpendicular to the tangent at the point of contact. And now I'm going to apply the trigonometric ratio. And since we have to obtain the relation between OR, which is a hypotenuse, and PR, right? Hypotenuse, this is hypotenuse, and this is hypotenuse, and this is what? The base, right? So we'll be applying cos. So cos 60 is what? Base over hypotenuse. So base is what? Base over hypotenuse. As you can see, the base is PR and hypotenuse is OR. And how much is cos 60? Cos 60 value is half is equal to PR over OR. So now from here we do cross multiplication. We'll say OR is equal to 2 times PR. But now check here. OR we need to prove PR plus RQ. But we got 2 times PR. But we know in the beginning that I told you that tangent from same exterior points are equal. So I can say that PR is equal to RQ. Now, this is what I'm going to do in the next step. Let's say we have OR. This is OR is equal to, I can write 2 times PR as PR plus PR. And let's say this is OR is equal to PR. I can replace one of this PR, as you can see that PR is equal to RQ. So I can write RQ instead of this. This is RQ. And hence it is proved. So the two properties which is we applied here, number one is radius is perpendicular to the tangent at the point of contact, and the other property used here is tangent from same exterior points are equal. But don't forget that if a particular question, but I have experienced that mostly in case of triangles and trigonometry, application of trigonometry triangles and circles, application of trigonometry is there. Now let's move to the next question. Now we are on the last question of this video, and if you have reached till here and have found this helpful to you, you should you please subscribe and like. That encourages me to do more, upload more videos, make more videos. Now coming to the question here, the diameter of two concentric circles are 10 and 6 centimeter. So there are two concentric circles. Well, what is concentric circles? The two circles having the same center and obviously different radii. So we are given two circles, and the radius of the larger circle is 10, and it's not radius, the diameter. And for the smaller circle, it is 6 centimeter. AB is the diameter of the bigger circle, and BD is a tangent. So AB is a diameter, and BD is the tangent to this smaller circle. And D is the point of contact here. Right. What else we have? We have, that much. And intersecting this tangent is intersecting the larger circle at point P. What we have to find out is the length of BP. This is what we have to determine, BP. Well, we have a similar question in textbook. Now, first thing that you will do here is to join this center with the point of contact. Right. What we know that the radius is perpendicular to the tangent at the point of contact. So I can say this is perpendicular. Right. Now, once we have, and this is, I'm talking about the inner circle, right? So you must focus. We are talking about this inner circle here, because this is radius of inner circle. So here it is for the inner circle, and you can figure out that this is a tangent. This is a tangent, and OD is the radius. So using this property, radius is perpendicular to the tangent at the point of contact. So we'll say that OD is perpendicular to PB, and you must write down the property here. Now, once you got this as 90 degree, let's figure out what is the length given here. The length, the radius of the larger circle has to be what? Half of 10, that is 5. So I can say this is 5. That is OB here, right? OB is how much? 5. And how much is this? OD has to be 3 here, right? As you can see that the diameter is 6. Now, let's figure out the triangle where I can apply. I'm talking about this triangle. In this triangle, we can use Pythagoras theorem. So what is the other line? OD as 3. Well, anyway, 3, 4, 5 is Pythagorean triplets. You are, if you remember, you can directly write down. But for those who do not remember this, for that I'll do this. So square of the hypotenuse is equal to sum of the squares of the other two sides. So OB, which is 5, so it's going to be 5 square. OD, which is 3, so it's 3 square plus BD square. 5 square is 25, 3 square is 9. If I transpose, I'll get BD square as, what BD square is 16? It should be. So BD is equal to what? 4 centimeter. Okay, we got BD as 4. So I'll write BD here as 4. BD as 4 centimeter. Now check here. This time I'm talking about for the larger circle, bigger one. This is the circle. Now look into this circle. For this circle, what is PD? PD is what diameter? Sorry, PD is a chord. For this larger circle, PD is a chord. Ignore the inner circle for a while and just look into the larger circle. This is a chord, and this is what? The perpendicular drawn from the center. So what we know, perpendicular drawn from the center bisects the chord, right? So we will say that since OD is perpendicular to PB, so we can say that PD is equal to PB. Well, I forgot to write that here, perpendicular drawn from the center bisects the chord. You must write in the exam. So we can say that this whole PB will be twice of, these two are equal, this and this are equal. So we can say that this PB is twice of PD, and twice of BD, sorry, twice of BD. And how much we got as BD as 4 here. So we'll say that PB's length is 8 centimeter. That's how we'll do this question.